After this Fusion Tyre tutorial, you'll master efficient combinations of surface and solid modeling workflows. Keyboard shortcuts appear in the bottom left corner when used, starting with the new activated internal component. Your model begins with a new sketch. I recommend sketching on a vertical construction plane to position your project at a natural angle, aligning with the final tyre orientation. The sketch for this design can be surprisingly simple, just 2 lines. Dimensions aren't critical for the workflow. I'll size my tyre as a toy tyre, making it clear that factors like friction, traction, rolling resistance, aquaplaning prevention, and load distribution are beyond the scope of this tutorial. Keep some distance from the origin, as we'll use the center axis to revolve our open profile and form the tyre's base. The simple sketch works well, but drop a comment below if you're interested in a video tutorial covering user parameters. We'll use the surface modeling Revolve command since the solid modeling version requires closed profiles. Our profiles are pre-selected, just proceed and check the red axis. I'll set the extent type to full since that's exactly what we need here. Taking a quick look at the model from different perspectives using the view cube is a good habit. It helps catch errors early and improves the final result. The view cube is also a great alternative to the orbit tool when adjusting perspectives. Next, fillet the edge to achieve a rounded look. I'm not overthinking the radius or exploring every fillet setting. The goal is to create a tyre, not the perfect tyre. Once you've mastered the overall workflow, you can fine-tune your design as needed. The Thicken command is a must-know tool once you start using surface modeling workflows. Like the Extrude command, it lets you work in multiple directions. I'll thicken my design by -5 mm since I want to thicken in the opposite direction of the original arrow. We can continue working on this side of the model and use an extrude cut operation to remove 2.5 mm. A quick quality check confirms that everything looks good on both sides. We'll add a fillet here for a smooth, rounded look. We're not diving into fillet settings now, but check out my video library if you want a deeper look into fillets. Let's get back to the rear of our tyre model. I want to extrude the back, but for some reason, maybe due to the fillet settings, I can't select and extrude this face. If you know why, drop a comment with your explanation. Instead, I'll work around it using another tool. Since our model is centered on the preset construction plane, we'll create a new sketch on this plane. Then, we'll use Sketch Project to generate a new profile linked to the original geometry. You'll recognize the projected sketch lines by their purple color. We'll extrude the model twice, and it's important to set the extrude operation to new body each time. Doing this will help us set up the tyre tread you saw at the start of the tutorial. I set the first extrusion to 4 mm and the second to 2.5 mm. With my current settings, it's hard to distinguish between the extruded parts, but we'll adjust those settings soon. Quick check before moving on. You should have 1 hidden surface body and 3 visible solid bodies at this stage. Press Ctrl+5 to enable shaded with hidden edges. This setting reveals useful lines between our solid bodies, making it easier to see the separations. Many Fusion commands do more than just add material. The pipe tool, for example, works great for shaping parts of the tyre tread on this toy tyre. When selecting the line between the solid models, Fusion automatically suggests a cut operation. Plus, it remembers our 2 mm cut distance when we create the second pipe. Everything looks good so far, and now we can move on to adding a pattern on the tyre shoulder, which is the side. Since the geometry is curved and tricky after the fillet, instead of sketching directly on the tyre, we'll set up a construction plane above it. This offset plane will serve as a base for a new sketch. The distance doesn't need to be exact, but leave some room for adjusting the tyre's dimensions later. Alternatively, you can set a reference with a fixed distance from the tyre. There are plenty of tools for creating the tyre pattern on the shoulder. I'm not sure why Fusion reorients the view when I create a sketch, so I'll just adjust the view before moving forward. I'll use an overall slot, which I find to be a useful and versatile sketching tool to have in your toolbox. The positioning doesn't need to be perfect. Let's create something, and if the result isn't what we want after adding the 3D feature, we can always go back in the timeline and update the sketch. We'll use the emboss command, but switch to the Deboss effect to achieve the depth we want. The clear symbols next to the setting highlight the difference. Alignment settings are outside the scope of this tutorial, but you can find them demonstrated in another video in my library. The positioning of the Deboss effect is good enough for this video, so I'll move on. No one will want to watch me perfect the slot sketch settings at this point. We need more of them though. To do this, we'll use a circular pattern, which is an easy way to add multiple effects. This also lets us edit the entire design by simply changing the sketch feature, the circular pattern, or the Deboss effect. Pay attention to the object type. You'll want to select features since we're making a pattern from the Deboss effect. Also, notice how easy it is to pick a good axis, since we created the design around the central axis earlier in the tutorial. The distribution setting is perfect at full, since we want a complete distribution around the entire tyre, and the quantity of 36 is definitely better than 3. We've come a long way, and our tyre is starting to look great, but there's still plenty of useful workflow to explore, so let's keep going. We'll add the appearance now, even though we only have one side of the tyre. No need to type the exact search words. Just searching weather brings up the weathered rubber appearance, which is perfect for this tyre. Instead of applying it 3 times, I'll select all 3 bodies first and apply the appearance to the entire selection at once. I've added the rubber appearance at this stage because the next step is creating the tyre markings, which will give a bold white color. A new sketch on the outside of the tyre will be the perfect starting point for this. After selecting the sketch surface, I recommend using the project tool to capture the tyre's geometry. This method is both fast and accurate, ensuring the sketch remains linked to the original geometry for future updates. We'll create text on a path by offsetting the projected line 4 mm, giving the path some distance from the tyre center. Then, we'll switch the text type to text on path and select the path. The sample text is too big, but I'll add the tyre markings first before adjusting the settings. This way, we get a clear idea of how the updated text will look. A height setting of 5 works well, and I'll leave the other settings as they are since this text is good enough for the next steps. Extruding the text will create many new bodies, so let's open the bodies folder in the browser to better understand the extrusion and prepare for the upcoming appearance. When extruding the sketch containing the tyre markings, set the operation to new body. This ensures each extrusion remains separate from the tyre instead of merging with it. You'll see multiple new bodies appear in the browser, making it easy to apply color to all of them at once. Body 4 is the last body that belongs to the tyre, so we need to apply an appearance to all bodies from body 5 through body 16. Instead of adding the white matte appearance to each one individually, I'll hold Shift, select body 5 and body 16, and automatically highlight everything in between. Now, we can apply the appearance to all selected bodies at once in the browser, ensuring the tyre remains black while the markings get the matte white finish. We're almost there, and we'll reuse everything we've created. Since we extruded new bodies that extended past the existing construction planes, we can't use them for this step. The solution is simple. Create a new offset plane on the back of the tyre. Press Enter to confirm the offset plane's position. If you haven't saved your project in a while, now is a good time. Activate the mirror command and select all bodies before choosing the newly created offset plane as the mirror plane. A join operation works well here, merging the mirrored parts of the tyre. Alternatively, you could combine all bodies first, then mirror and join them in one step. The tyre looks good, and it'll look even better after a small adjustment to our settings. We switched to a shaded view with hidden edges earlier in the tutorial to make working with the pipe cut tool easier between different parts of the tyre. Now is a good time to switch back to shaded view by pressing Ctrl+4 on your keyboard. The details look great from multiple angles, and they look even better with the upcoming rendering settings. I'll walk you through them while also sharing some recommendations for further learning. With details like the tyre markings, we'll need to ensure the rendering angle keeps the text readable. Right-click and open Scene Settings, then change the background from solid color to environment. Fusion offers several great environments. I'll use the Crossroads environment for this rendering. A useful tip is to explore different angles before starting the rendering. Set the resolution to 1920 by 1080, which fits this video format. Then, press Render and wait a few minutes for the completed rendering to appear in the rendering gallery at the bottom left. Here are the results from 3 different renderings. Let us know in the comments which one you prefer and what you would do differently. If you enjoy getting creative in Fusion, I highly recommend this tutorial on designing a sleek 3D printable vase. And if you hit subscribe, I'll see you again in another video soon. Thanks for watching and happy Fusion modeling!